TCP. And you've been told multiple times that TCP involves business and economics, and here is a bona fide professor from the Department of Economics who's going to tell us about things like royalties and, let's see, what else is he going to tell us about? Oh, you guys didn't read the assignment. I'm sorry? Patents, yes, patents, royalties, and?
BLP.
Come on. So now you're all scurrying around reading your emails. Okay, so this is Professor Scott Savage of the Department of Economics here at the university. He's going to tell us about smartphones and all of those kinds of things. So please welcome Professor Savage.
Thanks, Jim. Appreciate the invitation to speak to you today. The talk today, no surprises, is going to be very economics-based. It's actually the underlying tools used in this paper are very sophisticated and complicated. I'm going to try and avoid that and just talk more about the intuition of the paper and kind of what the results are and where it's useful. The other thing I'd say, this is part of a broader, I wouldn't call it research agenda. It's more my involvement in a number of patent cases in the last 5 or 6 years. And those cases are very much interdisciplinary. I'll talk much more about that in a moment, but I just want you to be aware of that. One disclaimer before we get going, this paper is a method paper. It's showing you how you can go about valuing a patent with certain type of data. And we're going to present some scenarios, but I just want you to know that they're all hypothetical. They're made up, okay, for demonstration purposes. I'm not suggesting that any of the firms are actually infringing. And I mean that seriously. We're on video here, and I don't want to offend any firms or anything. It's all examples. The technology we're going to use for the example is near-field communication. Most of you will be aware of it. It's used a lot on smartphones and other devices, and it basically just allows short-range contactless communication. Some examples there would be mobile wallet, or you already know about bumping your phones to download your friends' photos or something like that. It's, again, hypothetical. I'm making it up for this case, but if you're actually interested in real cases, there are a couple that have been through the courts. One's still ongoing. If you're interested, you can go away and read about them in your own time. Okay, just to start off, I mean, we all know we're in a telecom, engineering, building. Intellectual property is a huge part of the economy, especially the information economy. And a part of that intellectual property, one of the goals for firms is to protect it. And you can use a patent to protect your intellectual property. And it just gives you a property right, okay? It gives you the right to use your invention, to sell your invention, and also, importantly, it gives you the right to exclude others from using your invention. So you might want to sell it to firm A, but not to firm B, okay? So it's just giving you a proper property right so you can reap the benefits from your investment in that particular invention. The patents surrounding wireless and cellular technology are huge. It's one of the biggest. If you look at the distribution of patents, 16% of active patents in 2012 in the United States. I'll give you an example, like pharmaceuticals, you'd think there'd be a lot of patent activity there. It's only 6%. So you're looking at 3 times the amount of pharmaceutical patents. There's been some really huge damages awarded by the courts in recent years. Everyone's pretty familiar with the Apple-Samsung case, where Apple accused Samsung of violating some of its design patents, won the case. The settlement was just over $1 billion. A less familiar case, still ongoing actually, the initial award was $500 million, but this is VanetX, who accused Apple of violating some of its privacy and security patents. So these are large amounts of money, and as economists, when we start seeing large amounts of money, we think this should be estimated or carefully thought about, carefully estimated, okay? And the way I'm going to go about it in this paper is just incremental profits. And I'll talk more about it in a moment, but just think about, we have a world where no firms are using the patent, and we can calculate profits for all the firms in that world. And then we'll go to another world where maybe one or two firms are using the patent, and we can calculate all the firm profits in that world. And the change in profits, incremental profits, gives us a measure of the potential value of the intellectual property. Feel free to ask questions anytime. I don't know what the usual protocol is for this seminar, but just put your hand up and ask if you'd like. Just a couple of things about the literature. There's a massive literature on patents in economics. It's done really, really well, especially the theory side. I won't talk about it, but a lot of it's just to do with firms using patents to soften competition, to deter other firms from coming into the market. That's a really good theoretical literature. It's outside the scope of this paper, but I just want you to be aware of it. The literature I'm related to is the measurement of patent value. And I would just say, given I've written this paper with my colleagues, that it's very questionable. If you look at it, if you look at the studies, it's not very robust. And a lot of the studies aren't based on, formal economic theory and models. One way to do estimation is by looking at patents or royalties or citations of similar products. So you might have a product you want to estimate the value for. You try and find a product that already has, some sort of royalty in the market, and you try and match them up. It's crude and often inaccurate. Excel spreadsheets, I use this as a generic term for kind of Excel models. When I first got into legal cases about patents, it was in 2014, and the law firm that contracted me for the very reason that they had been doing these sort of Excel spreadsheets, and I can't go into a lot of detail, and the judge in their particular cases said, you know what, this is not good enough. You need to go out and you need to hire some economists and get them coming in with their, firm foundations of supply, demand, and competition, and do some better modeling, okay? And then when you think about modeling, I just want to quickly touch on, two types of modeling. This is going to be profit calculation. A lot of you guys have done my class. You know that profits are about supply and they're about demand. So thinking about how we're going to go about this, you need some sort of credible demand side estimation. And that can be done a couple of ways. One way is what's called stated preference estimation. And these are experiments. And this is done when you don't know or you don't have very good data on the patented characteristic that you're interested in. Okay, so maybe I'm looking at a smartphone, okay, and it has a certain feature, maybe a design or feel feature, and I can't measure that feel feature in real-world data. If I go and buy data from a company about sales of smartphones and I look at the data, there's no way of measuring the feel or the touch of the phone. It's kind of very difficult to measure. So one way to estimate or measure and estimate that type of feature is to do an experiment. And this is where people go out, draw up experiments, maybe offer people 3 or 4 different choices. You vary the choices by the feel of the phone and prices and other characteristics. People make their choice in the experiment, and you use that data to estimate the value of the feature of the phone. It's called stated preference because people are expressing their preferences. They're stating their preferences, but they're stating them in a hypothetical experimental world. Okay? So it's got advantages like I just mentioned, but it's got disadvantage in the sense that this isn't real. They're experiments. Okay? Revealed preferences is the data I'm going to use in this particular, in this talk, and that's where people are actually expressing their preferences or revealing them in the market. So this is data from actual sales of products. Okay? We know the sales of the products, we know the prices, we know the characteristics, and we can use this data to do revealed preference estimation. And that's one of the contributions of this paper, to really move the application or valuation of patent application more towards revealed preference data. Another way of thinking of this data is it's market data, and it's just going to be, you could look at a spreadsheet and what the data would look like for smartphones. You would have a model, you would have a period, and then you'd have information on sales, prices, and all the characteristics that describe the smartphone. Its weight, its diagonal size, its storage capacity, its CPU, whether it has 4G or not, whether it has NFC or not, all this sort of stuff. And if we have this information, we can estimate demand, but we also can use that estimation to say something about the supply of firms. And if we have demand and supply information, as you know from Econ 101, all you have to do then is make some assumption about competition, about how firms compete with one another, and it's possible to simulate profits in the market. Okay? We'll simulate what firms supply, what consumers demand, we'll figure out the equilibrium, prices and quantity, and then calculate profits. And then from those simulated profits, can do that incremental profit calculation. I want to speak briefly about the role of the economist here. In this research, this is strictly about incremental profits. So this paper is all economics. Me and my two colleagues, we're all, two economists, one applied econometrician, just an economic statistician. Okay. In practical cases, when you're involved in a court case, it's very interdisciplinary. Okay. You'll have the plaintiff will make some accusation against the defendant that they're using their patent or patented technology illegally. And it's more complicated than this, but there's three key aspects of the plaintiff's case. And the first one would kind of involve you guys and your background. It's a technical expert, someone with engineering expertise, a computer scientist maybe. And what they do is they come in and they read the patent. And they read it very carefully and read through all the technical details. And what they do is convey the teachings of the patent to me, the economist. So they'll say, hey, Scott, I've read this patent, and what it means is if the other firm uses this technology under certain conditions, for example, when they use 4G technology, the speed of their service will increase by X%, say something like that. And then what I do as an economist is take that information and put a value on it, okay? Incorporate it into the consumer demand function and try and put a value on it with supply in terms of incremental profits. And then I take that incremental profits and I hand it off to what we call a business expert. And the business expert conducts a hypothetical negotiation. Okay? The business expert sits down and says, oh, I have this measure of profits. That's kind of like a high-end value of what the patent is. And now I'm going to sit down and if we did some sort of valuation with the plaintiff and given bargaining power of the defendant and the plaintiff, we're going to come to some agreement of what the reasonable royalty should be, okay? And that's how it's done. And you can already see I'm in the middle, so I'm talking to the technical expert, and you have to talk quite frequently, and you have to use language that each of you understand. At the end of it, I'm feeding my inputs to the business expert, so the business expert has to be very clear on what I'm doing and what my assumptions are. And then overriding this, and this is really one of the most interesting aspects of it, I'm just talking as an applied economist, sort of stepping out of my department and doing real world economics, applied economics, is the lawyers. The lawyers are involved in this and they have very definitive legal strategies, okay? And you're constantly interacting with them because they have their legal strategy about how they want to attack the case, and that might gel with what you're doing. Often it does, sometimes it doesn't, and you have to kind of find common ground. And the other thing about it is what makes it really interesting, there's multiple lawyers, okay? Typically in a case, you're working with 2 or 3 or 4 lawyers on your side, 3 or 4 lawyers on the other side. So there's a lot of different strategies, including where you want to have the particular case, because there's different places or different courts in the United States where it might be deemed more favourable, I'm just giving you legal speak, where it might be more favourable for a particular case. Okay? So that's the interdisciplinary aspect. It's really, really interesting, but I just want to make it really clear, this paper is just about incremental profits. Okay. Like I said, I'm going to talk you through a lot of stuff. Is any questions so far? Okay. All right. So this is applied economics. We're using data and theory to estimate firm profits. We need a model. Okay, a lot of you that have been in my class, you've seen theoretical models. This is a little different. It's an empirical model. It's based on theory, but ultimately it's going to involve some sort of estimation. So the first thing I have to do is specify market demand. Okay, what do consumers want? What are their preferences in the market? And market demand just means we're going to look at product shares or market shares. So I know this, I can look in the data, I can look up this particular phone, and I can go in December, quarter 2016, this phone sold so many units in the United States. Okay? And then if I know the full list of sales, or I know the full list of potential customers, I can work out market share. And if I know market share, I have information on demand. And I'm going to express that information on market share as a function of the characteristics of the phone, okay, all the little features that comprise this phone, the preferences of the consumer. Guys from my class know about this, marginal utilities, the marginal utility for weight, the marginal utility for size, the marginal utility of storage, all these types of things. And then there's going to be an unobserved component. Because this is estimation, the economist, and this is very critical to understand, is outside the market. The economist is outside the market looking in and trying to model consumer behaviour. They don't perfectly observe consumer behaviour. Okay? There are things that the consumer thinks about and does when they make their choice that the economist just doesn't get to see. And the way we take care of that in econometrics is we say we have this unobserved component. Look, it's just there. It can measure a whole bunch of things. I don't know what it is. I'll make some distributional assumption about that, and that'll allow me to proceed with estimation. That's the demand side. You also need a supply side. You've got to model the firms in the market. And the supply assumption here is very straightforward. It's a Bertrand game, and I'll just tell you what, it's a game about price competition. All the firms are in the market, and they simultaneously sit down and think about their own prices, their own demand function, and the prices and demand functions of all other firms, and they choose their own prices. From my class last year, you would know what Bertrand pricing is. Going to assume constant marginal cost, okay? This just means the marginal cost of producing more output stays the same. It's positive, but each phone, as it comes off the manufacturing plant, and let's just make up a number, the cost of that was 200, the next one is 200, the next one is 200, the next one is 200. The other key assumption here is that this is a static model, and when I mean static, on the supply side, there's going to be no entry of firms, no exit of firms. It's a simplifying assumption. It's pretty reasonable in the data that we look at, okay? But what it does is just make this model a lot easier to estimate. If I have this information, I can specify a profit function, okay? This is the key to the analysis, the key to the evaluation. It's not hard here. Don't ignore all the subscripts. We've got the price of the product. We subtract the marginal cost of the product. This is just the share times the market size. So you have a market of potential customers, and the firm's going to sell to some share of them. So you're my market. Maybe you're the United States of America of potential buyers of smartphones. That's M. Okay? Some share of that, maybe this quarter of the room over here, is going to buy my model. So the share times the size of the market tells me my demand for my product. So that gives you here net revenue or variable revenue, take out fixed costs, okay? I'm going to use this profit function to simulate incremental profits. And okay, what is incremental profits is, I'll just come over it, come back to it. We're going to set up a market, all the firms, set up demand, and we're going to have the firms, and we're going to probably, put the characteristic on all the firms, calculate prices, shares, and profits, and then we go to our next market and we take the characteristic off the phone that is related to the patent infringing technology, and then we just calculate profits between the two, and the difference in profits is just the potential value of the patented technology. This is the change in profits here. B just means baseline. N just means new. So we compare profits in the baseline without the patented technology to the profits in the new equilibrium with the patented technology. Just to give you a little bit idea about estimation, in the baseline, I know firms' prices, I have it from the data. I know shares, I have that from the data. I know market size, and I know X, the characteristics of the phone. I know all that from the data. So given all that, I can estimate marginal costs. And then I just take that marginal cost and I plug it into the new simulation, the new equilibrium. Often it's the same, But if the patented technology costs something like $10 or $20, it's easy for me to add that on here. There's no estimation. In the new equilibrium, I have to estimate prices and shares. Shares are a function of prices. All this means is it's a very complicated, non-linear system of equations that you have to estimate, okay? So that's why, if you're thinking about how Scott going about estimating this profit function, he wants to maximize profits. You get a first order condition. You set up all the first order conditions for all the firms. It can be really, really large. Inside of those first order conditions, there's a lot of non-linearities, and you just solve this out with a non-linear optimization routine. Okay, should have just showed you this in the first place probably. What's all that mean visually? Think of it like this, okay? The black line is the demand curve here of a firm with the patented technology, okay? So the firm has this patented technology. It has a marginal cost. It sets marginal revenue to marginal cost and has a high price, high quantity of sales, P star, Q star. So the question we're asking is, how valuable is this patent? Well, one of the answers is, well, what would the firm's profits be if it didn't have the patented technology? If the firm didn't have the patented technology, it's equivalent to saying you're taking off one of the characteristics of the phone, or you're degrading the phone. If we think of NFC technology, that would mean this demand curve would be for a phone that has near field communication capability. This demand curve here would be for a phone that doesn't have near field communication capability, okay? And because that's valued in the market, how do we represent that? It's just a shift in the demand curve towards the origin, okay? For a given quantity, just draw a line up, the valuation with near field capability is much higher than the valuation without. So this W, you can think of it as the consumer preference for the patented technology. When we take that technology off the phone, the demand curve shifts in. The new equilibrium is just where marginal revenue equals marginal cost, and you get a sense of what I'm talking about now. This rectangle here is firms' profits when they have the patented technology. This little red dotted rectangle is firms' profits when they don't have it. I want incremental profits. I just want to measure the difference between those rectangles, okay? I want to know, in a simple linear world, what these lengths and what these heights and lengths are, okay? So you're looking at this stuff. I know, what does this mean? Well, this is what it means visually, okay? We're trying to figure out what happens in the market in terms of shifts in the demand curve when we enhance a phone or take a product feature away from a phone, and then what that means for equilibrium prices and quantities and profits. Okay? Any questions? Because this is the heart of what we're trying to measure here, right here. Okay? In a court case, you would not talk about this. Well, it depends, but this is definitely in your report, be a big detailed report, but when you're speaking to other lawyers and juries, this is probably what you would show for obvious reasons, okay? Most people know about Econ 101 and can kind of relate to demand curves, supply curves. This stuff can get a little bit complicated, okay? All right. The method can be applied to lots of different industries, lots of different products. We've applied it to the smartphone industry. There's some interesting aspects about the smartphone industry about why you want to look at patent valuation. I think the first thing is, over the period of interest, there was a lot of money being made in this particular industry. The bottom line represents revenue. It's above 10 million, approaching 20 million for a large part of that period, 2010 to 2015. So there's a lot of sales of handsets. There's a lot of revenue in this particular industry. There's a lot of profits. So a lot of profits mean people get interested, okay? People inside and outside of that industry start to think, why are they making so much money, okay? Is this, they're using something of mine, they're using my technology, and I licensed it correctly in the first place? You know, these sort of questions. I think the other interesting thing about the smartphone industry is the convergence of voice data and multimedia. So you got phones become really complicated devices. They have a lot of things going on in them, and there's a lot of uncertainty. No one quite knows who owns what and whether they're licensing the right, you know, got a license of the correct feature. There's a lot of cross-licensing, and sometimes you're buying components and you're not really sure if the supplier of the component has a correct license. So that leads to a lot of uncertainty. The other really interesting thing about smartphones is it shows a real clash between traditional telecom companies and computing companies. You can think of like the traditional companies such as Ericsson, Nokia, Motorola, okay? These traditional companies that were really kind of hardware-based companies, you know, building telephone equipment and telephone components. And for a long time, these guys coexisted with a lot of cross-licensing arrangements and just steadily existed in a fairly static world. And then all of a sudden, you have these computer companies coming into the market, your Apples, for instance, even Sony and Microsoft, and they're coming in with more of a handset mentality, and they're more about software and even design, okay? And that's completely at odds with the telecom companies. And a lot of the telecom companies see their revenues go down, and they're watching these smartphone companies, computer companies' revenues go up. They're asking themselves, you know, why is this? Where have we gone wrong? Are these companies using some of our technologies? You know, are they paying for it correctly? They have different philosophies as well. I think that's really interesting. As I've already mentioned part of it, the traditional telecom companies, there was a lot of implicit arrangement and agreements. We would just say, okay, you can use my standard or my patent and I'll use your patent, and they would just agree to do that. They wouldn't worry about writing out contracts and such. Whereas the computer companies, you know, lot different. Codified, you know, patents, contracts, and then also, strangely enough, willing to ignore the legal aspects of patents for certain periods of time. I'll come back to that towards the end. What this means is if you sort of add this all up, there's a huge scope for, or broad scope for infringement in this industry, and there is. Okay, there's lots and lots of cases. They're in the media all the time. You just go online and look up smartphone court cases for patents, and you'll just see lists and lists and loads of them. Yeah.
So how will we know that other companies using our technology?
Like on what basis will we actually know that?
Oh yeah, I mean that's there's two aspects to that. First, the lawyer, you know, you'll get some information. There's a couple. I mean, the first one is maybe they had an agreement already, okay, and the agreement's run out. Maybe you had an agreement and you're not happy with that agreement anymore, and you want to renegotiate. Maybe you've just found out through legal investigation or business investigation that someone's using that patent, okay? And then it's up to the lawyers to establish that they're actually using it, okay? That's a different, you know, an assertion that you're using my patent is different to actually you are using my patent, yeah. And again, a lot of uncertainty there, isn't it? And this plays out in the courts. Before we even get to the economic estimation, there'll be this huge process of whether someone is even using my patent in an illegal way. Okay, and there's a long process to get there. Exactly. Someone else over here? No? Okay. The data, it's for 22 quarters, and it's for phones, smartphones. For each smartphone in the data, and you have all the models, you know their sales by quarter, you know the revenue by quarter, so you can back out prices, and then there's a whole list of information about the characteristics of the phone. I've just listed the ones we're interested in this study, but these are sort of things that consumers feel importantly about. In writing the economics of the paper, I would have to provide fairly strong justification about why am I using these. My first one would just be, hey, it's in the data. It's all I have. Okay, and that's pretty standard economic assumption, justification. I can only use what I have. That's the first thing. The second thing would be, well, you know, if you go through and read a lot of the marketing literature, if you go to the websites of these particular phone companies, what's the sort of things that they advertise? These characteristics, okay? You write in Apple, iPhone, bang, up you go. Here comes the Apple website. It lists out all, you know, you get these pictures, what is it? Columns of all their different models, and then down the side it'll be all the features, and it ticks and checks all these types of things. Okay, so these are things that the firm knows the consumer is interested in, and it's just storage in gigabytes, screen size, you know, inches diagonally, speed of the processor, number of cores in the chipset, the megapixels of the camera. I think most of you guys understand all this stuff. Pixel density, hours of battery, talk time, 4G or not, NFC or not, price, brand. What do I mean when I say brand? What am I talking about? How am I measuring brand?
Sexiness of the phone.
What's that?
Sexiness of the phone.
Yeah. I mean, basically what we have here is the manufacturer's name, and consumers attach different values to the manufacturer's name based on their own perceptions of what that conveys. You know, maybe the Apple phone conveys an image of quality or sexiness or hipness, okay, as opposed to the Samsung phone. But that's very, very important. It's extremely valuable, okay? It's probably the most valuable thing in the phone when you estimate it. The data is from International Data Corporation. I got to give them a plug because they've been pretty helpful to me and my colleagues over the last few years. They've been, I mean, when you do the court cases, you just pay full price. You know, it's a business transaction. But when you do academic papers, they've been really nice in being able to give us some data at a relatively cheaper price for academic purposes. If you need any data on tablets, computers, smartphones, or anything, I would go to those guys first. They had really good data. Second thing, what's missing from IDC, you have to find yourself. Fortunately, smartphones data, there's lots of it on the web. I think I'm trying to think of the one, GSM Arena. Is anyone familiar with this? Yeah, you just go on, it basically lists every model that's ever come out and all the characteristics. So when there's gaps in this data, you just do the good old-fashioned economic research where you get on and you just fill in the gaps by going online and finding that data. Here's some summary statistics so you just know a little bit about the data. You know, so this is, I mean, you can think of the typical phone as being $369. It makes sales of nearly 200,000 in a quarter, and then you can just read down, you can see that, you know, it's around 11 gigabytes of storage, 4 inches of diagonal size. Go down to the bottom. I think the more interesting values are these ones here. At this point in time, over our sample period, about 40% of phone models had 4G and about 30% of phone models had NFC, near field communication. Age is the number of quarters since the phone was released. Okay? So the bigger this number, the older the phone is in terms of its vintage. Just some more summary statistics. I want to talk about the top 8 firms. I'm doing this for a reason. One, just to give you some sort of sense of the supply side of this market and how it's kind of dominated by 2 or 3 large firms. That's the first thing. But also because when I do my simulation, I'm making up the market, and I'm basically going to use these 8 firms. I'll come back to and explain why, but this is just 2 reasons why I have this up. I mean, you look at it, this is just for the second quarter 2015. It's pretty clear that Apple are the dominant firm in the market. They had 38% of sales. Their revenue in the quarter from their smartphones is $9.6 billion. Okay? That's a lot of money. Yeah? This is it. You think there's a period there where just month after month, the money is just rolling in. And I make a point of this. If you look at Apple and Samsung, there's just billions of dollars rolling into these companies. Their share prices are increasing because of the rates of return on investment are increasing. And it gets back to my point earlier. If you look at Nokia and Motorola, not so good. And if you trace this out through time, it gets worse. So I'm thinking about, why are we seeing, more patent cases? That's one particular reason. Nokia and Motorola were giants in the industry, and they're seeing their share and revenue go down, and they're seeing these other upstarts, improve, and they're wondering how can they do that? Are they using some of our technology or not? Let's do an investigation. Right. That's one type of patent violation. Okay, well, I'm not even going to talk about how I estimated demand, but I just want to tell you that what's good about the method is it accounts for heterogeneity in the consumer market. So as I've talked about this in my class so many times about how everyone's different. Everyone has different valuations for different features, okay? And that's accounted for in the model really well. Basically what I'm going to do is estimate the market shares for each product as a function of prices and characteristics. And just for you guys, again, that were in my other class, this is all based on theory. It comes from an indirect utility function, which we spent a lecture a few weeks ago talking about in class. And I'm just using that exact method in my research. I just want to bring up a problem that occurs has been a long problem, problem in economic demand estimation since probably the beginning of time. And that is the correct estimation of the price coefficient. If you have a demand function and you're estimating a coefficient on price, you're getting the marginal disutility of price. And that's a very important parameter because it's basically telling you how sensitive each individual is to prices. And that's in fact a measure of what? What am I measuring? Sensitivity of customers to prices. What's it called? Demand. If I'm interested in if I'm estimating the sensitivity of consumer demand to prices, what measure captures that? I'll put this in, I'm putting this in the exam. Total failure. Class has failed. It's demand, price elasticity of demand. It's very important because the firms price their good according to the sensitivity of their customers. Okay? If my customers are super sensitive, like Apple's, they can charge a very high price. So estimation of this parameter in a model it's fundamental. If you get this wrong, your demand elasticities are going to be wrong in the model, and the prices that you infer from your price cost margins are all going to be wrong. So you can go do the simulation. It might be great, built on a great method, but its foundations are wrong. No one will believe you. Fellow economists won't believe you when you're publishing a paper. When you step into a court of law, opposition, the expert witnesses on the other side, they'll just slam you. So all I'm saying here is that there's a common problem in economic demand estimation where we typically underestimate price. And we typically estimate elasticities that are more inelastic, and that infers higher price cost margins that are actually happening in the market. And it comes about in this model, and I think it's worth talking about just briefly because, again, as the economist, I'm looking outside, I'm trying to figure out what you consumers are doing when you're buying. I know you look at price, and I know you look at the nine or 10 characteristics that I've written down here, but there's also some things that you're looking at that I don't see, okay? They're unobserved to me. And it's quite possible there's something that I don't see that infers quality. And you might pick a phone that has a high unobserved quality, which gives you a lot of utility, but it also has a higher price. I don't measure that. That's classic, what we call a classic omitted variable bias. I've got this confounding variable that I'm not controlling for in my model, quality. It's positively correlated with price because high quality goods have higher prices, and the person that gets the high quality good has higher utility. And that bias actually leads to pushing this coefficient towards zero. So I'm just letting you know it's all taken care of in this paper. Okay? Just talk a little bit about results. On the demand side, these are just the valuations of consumers for selected features, and they're converted to dollars. So in the model, these would be marginal utilities, and I've just converted them over to dollars using ratio of marginal utilities, where one of those is the marginal disutility of price. They look plausible. I would say overall the whole model looks pretty good. You would expect all the characteristics to have positive values. They all do. They're all statistically significant, and the valuations seem to make sense. If you take these away and you try and fit them to phones, it kind of, the valuations look kind of like the prices, and that's important. Lots of sensitivity checks. We don't have to talk about it, but that's a big part of estimation anywhere. Just check how robust your results are to different assumptions.
Those be additive, those characteristics?
Yeah, this is, so in the utility function, it's an additive utility function. Yeah. Okay, just quickly talk about the simulations. I have demand estimates, so that's great. If I have demand estimates, I can calculate, remember from the second slide, I can calculate market shares. Given market shares and prices and characteristics, I can back out marginal costs. And that's my first goal. I want to get these estimates of how much it actually costs to make a phone. So I'm going to, I've got my demand estimates. I'm going to use those in my simulations. Before I get to my specific simulations, I just want to let you know that the method is really flexible. Okay, I'm going to do specific examples, but this method could be used for a patent holder in or out of the market. And I want to make a distinction here. Someone inside the market is a firm that actually sells the product. That would be Apple v. Samsung. Samsung sued Apple. Apple owned the patent and also sold phones in the market. That's one type of case. Another type of case is when you're just a third-party vendor outside of the market. You're just an entrepreneur. You may be a company that holds a portfolio of patents. You might be, a company that builds technology, but you don't actually sell the phones in question or the product in question. Okay? We can do it for any observable product characteristic. My example's NFC, but you could do anything that you can measure. You could do a single or multi-firm infringement. Our examples are just going to be single firm. One firm in the market infringes, but you could do 2, 3, or all of them, okay? It also, and this is important for the law aspects, is you can look at best non-infringing alternative, because that's actually part of the law. You have to show in the legal side of things that, when you use the patented technology and it's taken away from you, you have, what is the alternative available to the firm? And in our case, there is nothing. You either have NFC or you don't. That's just our example. But you could easily apply this to like 4G. And if you take 4G off the phone, it doesn't collapse down to nothing. It collapses down to the next non-infringing alternative, which would be 3G. Okay? So again, totally applicable in the method. And the last thing, you could use all firms in the market and all products, or you could use some smaller representation of firms, okay? Here's a practical thing to think about. These simulations take a long time. You run them on your computer and they crank along because it's a pretty complex computation going on. So in the interest of time, especially when you're in a legal case, it might be better to try and simplify the simulation, okay? And that means just use some subset of firms that are representative of the market. And that's basically what we're going to do here. Instead of instead of putting 32 firms and 335 products in the simulation, I'm just going to use the top 8 firms. They represent 90% of sales in the market, so it's very representative. I'm not going to have all their models. Most firms have, like 2 to 7 different models. We're just going to have 2. They have a flagship, a high quality model, and a non-flagship model, lesser quality. And that represents the multi-product nature of the market. Here they are here, if you want to have a quick look at them. There's the 8 firms. There's the 2 models for each. Here's the prices taken from the data. I didn't have room to put all the characteristics in, but you can see storage, screen size. In reality, this is the firms that have NFC on their models or not. And then the last column here, I'll come back to that in a moment, that's our estimation of marginal costs from our model. Oops, sorry. Demand elasticities look reasonably good. They imply markups of 30 to 40%. It's reasonably consistent with what you see in other consumer goods like digital cameras and digital VCRs. I've also seen some other estimates in the wireless field. I think the marginal costs are reasonably plausible. The comparisons are hard because you can only compare them against so the teardown estimates that you see when you go online and you look at companies that break down phones and just add up the component costs. But they're pretty plausible. If anything, I think our estimates of marginal cost here, in some cases, might be a little high, but I would prefer that than them being a little low. If they're low, that means the profit margins are going to be bigger and I'm going to overestimate. I would rather underestimate profits than overestimate.
That's because of the court case?
Yeah, that's because of the court case. Well, and also, Jim, economists are naturally conservative, okay? And will often, their natural training is to always present the smallest estimate, isn't it? And that's kind of always how we train. So it fits with the philosophy, but definitely you want to put your lower bound estimates in a court case, okay? For sure, that's good strategy. Okay, so I think I got 5:50, is it, Jim? Did I get 5 minutes?
5:50, yes.
Yeah, this is good. Going good timing here. I'm just going to do 2 scenarios, okay? Actually, I'm just going to talk about one, okay? And you can look at the other one by yourself. This is a very simple scenario where we're just going to start with no firms having near-field communication capability, okay? So we strip that away from all phones, estimate profits. We then add near-field NFC capability to the flagship phone of the dominant firm. And again, I just made this up. I liked using Apple because they're the largest firm in the market, and that seems to have some sort of impact. What happens when we do that in the new equilibrium, share increases by 0.89 points and 0.14 points. That looks small, but when you compare it to the base case, it's a lot. I'll show you in a moment. So they get a big increase in sales. Their profits increase by 780 million, in a representative quarter, 29%. And this would be the basis for thinking about a reasonable royalty, okay? In this case, there's a company outside of the market who owns the patent, and they would do the estimation and they would say, hey, Apple, you're making 780 million extra in profits in this quarter when you add our patented technology to your phone. That's the starting point. That's the incremental profit. In fact, it's really the 29% because this doesn't necessarily match up perfectly in reality, and the lawyers and the business analysts would take the 29%. That's what's important because they can apply that to their actual numbers. And that would be the basis for the royalty negotiation. Something I quickly want to talk about, and I'm going to get to the conclusions in a minute, is that the other thing we kind of forget about, especially in the law cases, but in economics less so, other firms in the market lose. So this is not only the third party owner of the patent out of the market losing because they're not getting their royalty, the dominant firm's gaining lots of profits, but the competitors to the dominant firm, they lose too because their product is devalued relative to the dominant firm's product. They can't sell as many, they have to charge a lower price, and they lose substantial profits. So there's this sort of second order effect. Clearly it's not relevant to law, but it is relevant to economics, and I'll touch on it in a sec. Here's all I just quickly show you, it doesn't look like a lot, market share, but this is the market share of the total number of people in America in a quarter who could buy a phone. And that's like 300 million people. So, 2 or 3, a change from 2.3 to 3.2% represents a lot of increase in sales. I'm running out of time, so I just want to get to the conclusions. First thing, classic economist comment. This method is a fairly straightforward way to evaluate and value patents. Okay? I like to use straightforward in the sense of a court case. The court time horizons are very, very narrow. Okay? You get contracted, asked to do a case. The first thing they say is, can you have this done, you think, in X weeks? Okay? So you need a method that is robust and you can run fairly quickly. everything I've talked about today, I've talked a little bit about my assumptions. They're all in the paper. You would have to defend them rigorously in a court of law. Okay? You would be put up on the stand, depositioned, and would have question after question, line by line of your report. Fortunately, in economics, we do this anyway in our papers, so it's kind of natural as well. I think something I'm looking forward in this research is more acceptability by lawyers and courts. Okay? This is a standard approach we use in economics. Well, not standard, but the tools are reasonably standard that we use in other areas of economics. It would be great to have the courts officially sign off on these things, like say, yeah, this is the benchmark, this is the case, this is the precedent. We need these types of methods. There's a lot of future work here, but I just want to focus on the last one because I think it's a great way to finish because it's got some economics to it. It's about these firms that are in the market who are abiding by the law, doing the right thing, but they suffer because they don't have the patented technology and some other firm that is violating the law does. Okay? And this is really interesting when you think about sort of economics of why you'd want to violate a patent, and one of the reasons could be entry deterrence. This is a static model, but, and it's going to take me just a minute, sorry, I'm going to go 1 minute overboard, but I'm a firm, I'm a dominant firm, and I'm thinking, I'm not dumb, I have there's some probability I'm violating this patent. And then the calculation is, well, I'm going to make some profits, and there's some probability I'm going to go to court and get prosecuted and punished and pay damages. And this is all in the firm's calculation. It's going, oh, here's the profits I get if I violate the patent. Okay, there's a probability I get caught and I have to pay damages. Okay, what's my expected profits? But there's one other aspect of this. The firm might be willing to bear that damages. It might be happy to just violate, incur those damages because what's it doing at the same time? It's putting pressure on these other firms in the market, their profits are going down, and ultimately when the case is settled, some of these firms may not be in the market anymore, okay? No, so this is business strategy, entry deterrence. We see this sort of thing happen all the time where large firms with lots of resources go to the courts and just push back time until the other smaller firms in the market can't take it anymore and they exit. Okay. All right, I'm finished. Sorry, 2 minutes overboard. I don't know how it works, Jim. I'm happy to take questions or whatever you want to do. Wrap it up.
So first of all, let's thank our speaker. So patent law is in your future because you're going to be doing technology. And do we have at least one question, please? One question. One question.
It can be about anything too. I always tell my... It doesn't have to be about this paper.
Over here.
I noticed the data was from 2015. Is that right?
Was that right in what way? I don't know.
The data that
the
you
data
used.
is 2010 to 2015. Yeah.
Okay, so do you take into account how recent the data is, maybe in the last 3 years, a lot of stuff has changed?
Yeah, I mean, if you were to read, so first of all, this analysis was originally done in 2016. This economics has a long publication lag. So when I wrote this paper, the data was right up to date. I totally agree with you. Things have probably changed now. There's less revenues per quarter. There's a little bit more pressure on prices, and there might be some changes in strategic behaviour. I agree. You would just have to account for that in the current analysis. Okay? Yeah. Hold it, guys. There's a question here.
Along with the turn to market entry, by violating patents, firms like Apple, as law-abiding firms' profits go down, are they then tempted sometimes to violate that patent?
Yeah, I mean this has nothing to do with that. Inference is not in this paper, but it's it's a great question. Because you're here, you've got to do your calculation. If we keep doing what we're doing, and if we project out to time, we're not going to be around. Maybe we need to violate, or maybe we need to quickly make an arrangement with the licensing company. Yeah, exactly. Yeah, great question. But these are dynamic questions, and they're really interesting. I'm just making it clear this is a static model. Okay? Yeah. What, Jim? Did you have one, or are you good?
No, I was going to wait for the students. Keep them going.
Okay. Any more?
Well, then I'll ask one. On your marginal cost, marginal revenue curve where you show the differential profits, there's also some interactions there that
Yeah, I mean, this is,
showing a monopoly.
oh, exactly. So this is a good point. I should have said it, Jim. Just quickly go back to this pitch. I'm showing this where the firm has a lot of monopoly power because it's the best way to just demonstrate it. Okay, in reality, the firms have some monopoly power, but it's a differentiated product market. And in fact, there'd be lots of stuff going on in this picture, and it wouldn't be as clean as this. I totally agree. That's why we do the mathematical model. But this is just a kind of a abstract representation of what's going on. Yeah, totally.
So again, let's thank our speaker and thank you all.
Thank you, I appreciate it.
And of course, your papers are due, well, you know when they're due.